Dear students, today we will be discussing induction machines. And as we have already discussed the classification of electrical machines, as far as electrical machines are concerned, electrical machines are basically classified into two main classifications. One is AC machine and another is DC machine. Okay? And as far as AC machines are concerned, AC machines are further classified into two basic classifications, motors and generators. And we do call AC generators as alternators. You're supposed to say so, okay? AC generators are alternators, not. As far as AC motors are concerned, on the basis of the type of supply which we are giving, they are further classified into three-phase or single-phase motors. Now, as far as three-phase motors are concerned, the very important and the very first machine is three-phase induction motor that we have in the book. So right now, we have written material which is handwritten on the LED screen. I have made this material just to save some time. Now, without wasting further time, we'll come back to today's topic, which is constructional features of three-phase induction machine. Okay? And in case if you have any sort of doubts or questions, you feel free to ask, because this class is my private responsibility rather than the online class. Okay. Now, as far as an electrical machine is concerned, this three-phase induction machine, as the name implies, it has three phases, R, Y, and B. Just look over the diagram. We have three wires which are coming inside, R, Y, and B. And the three currents are IR, IY, and IP. Just remember, whenever the direction of arrow is towards the direction of the machine, it is a motor. And when the arrow is outwards, then it is an alternator. Fine? Yes, it's okay. Now, I have written certain points. On the basis of these points, it will be quite easier for you people to write this particular question in your examinations. So, if possible, try to write these points as it is. The very first thing is, the most common type of AC motor being used is induction motor. Rather, more than 90 to 95% of motor which we are using nowadays in AC circuits are induction motors. Okay? So, the most common type of AC motor being used is induction motor. Number one. Number two, induction motors are most rugged, less expensive, and require less maintenance. Obviously, whenever we are purchasing something, let us take an example. If we are purchasing a car or a bike, so we want to check it out that what will be its running cost, what will be its maintenance cost. Okay. So these motors are, first of all, they are rugged. They are pretty much hard. They won't undergo. You need not to go over maintenance very frequently. Then these are less expensive. In comparison with different machines, they are expensive. They are a bit cheaper. They requires less maintenance. Maintenance is also very less. Three-phase induction motor mostly consists of mainly two parts. One is stator and another is rotor. Before going ahead, I show you those parts on this particular diagram itself. Okay, just mention it on the diagram. Now, the very first thing is stator. Stator is the part which remains stationary, which is not moving. Okay, the very first thing is the outer frame. The outer frame of the machine, it remains stationary at a particular base. So this is the base where the motor stands, and this is the outer frame. Stator is also called a stator frame. So stator frame is a part of stator. Basically two parts, stator and rotor. So stator frame is the part of stator. Then in stator we have slots on the inner frame. We have did some slots on the inside, and those slots are being made in order to put some conductors in it. And those conductors or those slots are being filled with the stator winding. and the winding is made up of copper. We can use aluminium as well. We do have certain machines where we are using aluminium. Aluminium machines will be much more, much less expensive than the copper one. Copper is much expensive, but we prefer to go for copper. If you want to purchase a machine or a motor or a generator or a transformer for your own home, go for copper one, okay? Yeah. Because copper requires less maintenance, whereas aluminium requires more maintenance. Okay, now, so stator frame, which is made up of cast iron, and there is some function of this frame. The main function of this frame is to protect the motor from external damages and to hold these stator windings, okay? Then there is stator core. This is stator frame, the outside stator frame. That inside we have stator core. Stator core is made up of silicon and steel stampings. Why we are using silicon steel? We have studied it in your last semester, that silicon steel is being used to reduce the hysteresis and eddy current losses. Okay? Then we'll be using iron instead of silicon steel or simply steel. The hysteresis losses, the losses will be more. So in order to cut down the losses, we are using silicon steel, and that too, stamping of silicon steel. Not just one hard piece, saddings. Then sheet is being cut, then it is being laminated, and then a bunch of those sheets are being connected together to form the stator core. Now, so these are the major parts of stator. Then we'll come to rotor. Now we'll move forward. Okay. As I told you that we have two basic parts. One is stator, stationary part, and another is rotor, which is the rotating. Now as far as theory is concerned, just look on the LED screen. It says it is the stationary part and mainly consists of stator frame, stator core, stator face to protect the motor from external damages and to support the stator core. Okay, this is the function of stator frame. Now, stator core, it is made up of, are you getting a point or not? Because online classes are secondary. The prime responsibility is you be. I'm learning my bread and butter from you. Okay, so you must understand. Oh, now stator core. Am I going a bit fast, like limited speed? Oh, fine. Stator core, it is made up of thin laminations of silicon steel to reduce the hysteresis and eddy current loss. As far as stator core is concerned, as I have just told you, that is, it is made up of silicon steel. So silicon steel is to reduce hysteresis and eddy current losses. The material, just listen carefully, silicon steel reduces hysteresis loss, and the stampings, the thin sheets, those stampings reduce eddy current. We'll be studying about the losses in detail. Although you people have already studied, but still we'll discuss it once a day. Okay, now just move it in. Just stop. Then it says the thickness of each stamping / lamination varies from 0.35 mm to 0.5 mm. This is the thickness of all those stampings. Stator winding. 3-phase copper windings are placed in stator slots and 6 terminals are taken. So what we are doing is, in those stator slots, we are doing 3-phase distributed winding. And the material which is being used in the wire is copper. Okay? Yes. It is a 3-phase distributed winding and the material which we are using is copper. Okay. Now, that's all about the stator. Now we are coming to the most important part, which is the rotor. And let me tell you one more thing. Stator is same for synchronous and induction motion, or either rotor with the rotors and the So, coming back to the rotor is the rotating part of an induction motion, an induction loop. Believe me, students, you will not be able to find easier anywhere the most which will be easier than this. This is when hard work. So finally, just try to put it down on the piece of paper which you are holding in your hand, in your notebooks, and it has to be in. Okay. Now, the rotor, it is mounted on the shaft made up of silicon steel. The rotor is mounted on the shaft, which is in the middle. Okay? And that shaft is made up of SS, which is stainless steel. Okay? Now, the rotor core is mounted on the shaft and is made up of silicon steel stampings. The rotor core is made up of silicon steel and it is mounted on the shaft. Move it. Okay, this way. Rotor conductors are placed in the rotor slots and this mainly depends upon the type of rotor. So these rotor conductors are placed in the slots and it depends upon the type of motor which we use. Okay? Now, listen carefully. Depending upon the type of rotor, this is working? Okay, fine. Depending upon the type of rotor, three-phase induction motor has two types. Right? Depending upon the type of rotor or the construction of rotor, it has two types. When first is squirrel cage type rotor. And the motor which has squirrel cage type rotor, it is called as three-phase squirrel cage induction motor. Okay, now you might have heard the word squirrel, aren't you? Squirrel cage, it means it has a construction which is similar to a cage of a squirrel. As far as squirrel is concerned, if you remember something in your mind, squirrel keeps running here and there. So you need some cage which will not end while the squirrel is running. So normally whenever we have to put a squirrel in the cage, the cage is a round one with the bars of conductors. If the squirrel is running, that cage is not going to end. Okay? Yes. Okay? Fine. Now, the rotor looks like a cage of squirrel, hence the name squirrel cage induction motor is being used. And this is the type of rotor. End rail, one end rail, bars of conductors, and this is the shaft. This is the shaft on which the whole rotor is lying. Okay? Now the shaft is rotating. Whatever is fixed to the shaft, it will be rotating as well. So shaft is a part of rotor. This core is a part of rotor. These windings are the part of rotor. Fine. Move it. Now, come down. As far as squirrel cage rotor is concerned, no external resistors can be added. We cannot add any sort of resistors because in case of squirrel cage induction rotor, what we had is bars of conductors short circuited by end rails. Okay? Bars of conductors short circuited by end rails. So we cannot add or remove any sort of resistance in the circuit. So it has a fixed resistance. Whereas the other type of motor, which is wound rotor induction motor. So one is squirrel cage induction motor, another is wound induction motor, wound rotor induction motor. We may call it as slip ring induction motor as well. Now this is the last one, then we are done with three-phase induction. Okay? Just look towards the EDC. Wound rotor, it is also known as slip ring induction motor. It consists of copper windings in the rotor slots and 3 terminals are taken. Okay. So in squirrel cage, what we have was bars of conductors. We do not have any copper conductors in it. We had bars of conductors short circuited by end rails. But whereas in wound rotor induction motor, we have thin copper wire which is being wound on it. Okay? And we have taken 3 terminals out of it. And those 3 terminals which we have taken out of the rotor circuit helps us to add some external resistance. And how we are adding external resistance, that will be shown in the diagram. Okay, number. Okay, let's wait a bit. So these are the 3 rotor windings. Okay, now these windings are taken out with the help of slip rails. Because this is on the rotor side, which will rotate. Now, we need to have 3 stationary contacts out of the rotating one. So we need to use slip rails. So we'll use 3 slip rings and 3 connections are taken. And we can, over here, we can add or subtract resistance in the rows. And how this resistance is going to help, if we tell you that if we add some resistance in the starting, it will increase the starting torque of the induction. Whereas on 3-phase squirrel cage induction motor, we do not have any sort of resistance which can be added in the result. So we cannot control the starting point. Whereas in this particular case, by adding some external resistance, we can increase the starting torque. Okay? Once the motor starts, then this resistance is of no use. Then we just short this particular use. Okay? This is working right now. See? Oh, fine. So do you have any water doubts? Now, this moves, move it downwards, go to the top one, have a look over it, and if you have any sort of doubts, do let me know. So this is the main construction feature. Over here, this is the shaft, which is of stainless steel. This is the rotor core. These dots shows the rotor winding, which is of copper. Okay? Yes. That will be all. Just move ahead. Move ahead. Slowly here. Now. Is there anything you want to know about? If you have any sort of doubts, feel free to ask. And even if online viewers have any sort of doubts, you can put your comments. I'll definitely get back to you within next 48 hours. So that will be all. I'll be signing off. Thank you very much.